All right, welcome everybody to the final lesson of this unit on coordinate geometry. You're going to learn how to write equations of horizontal and vertical lines today. So that's our essential question that we want to answer. How do we write the equations of horizontal and vertical lines? You're going to notice a similar structure. This is the final lesson for this standard, for this unit. And just a reminder, I think Desmos will really help you out a lot today. So keep that tab open as well. All right, before we get into it, I want to go over a few common errors I noticed from your exit tickets, just like kind of structural things that we should talk about. So if you're talking about the slope of a line, 3/4 x is not the slope. Just the 3/4 is the slope. Okay, that's an important distinction. The 3/4 is just the rise over run. The x is the x coordinate. So you don't want to say 3/4 x is your slope. You would just say the number in front of the x. Similarly, in your next bullet point here, you can't leave out the x. So like this is actually not the same equation as this. So some of you forgot to put in an x right here next to the 3, and that's going to make your equation incorrect. So make sure that you have y equals a slope, and then x, and then the y-intercept if there is one. Finally, last bullet point here, if you are asked to explain why lines are perpendicular, you have to be more specific than just saying they have negative reciprocals. You have to say that their slopes are negative reciprocals. That's really the key part. So like if we had a slope of m equals 1/2, let's say actually m equals -1/2, the negative reciprocal of that would be positive 2/1. Okay, and one more quick distinction on that. Just because it's called a negative reciprocal, it doesn't mean that the result is negative. Like for example, that's the negative reciprocal of the slope that I wrote in purple. One of them is going to be positive, one of them is going to be negative. All right, let's take a look at our first example for today. So let's figure out how to write the equation of a horizontal line. So what you'll notice is a similar setup as we saw last week. Line CD passes through these 2 points. What's the equation? Okay, since we don't know the slope, let's go ahead and figure that out first. So y2 minus y1 over x2 minus x1. Okay, what you're going to notice here is that our slope is 0. Okay, so we've seen 0 slopes before. We know that 0 slopes are horizontal lines. So that makes sense that we're going to have a 0 slope for a horizontal line. Now, something interesting though happens is how do we actually write the equation? Well, let's try one of the methods we've learned already. Y equals 0x plus b. Okay, so we're just trying to figure out the b value. So let's plug in one of these points. I'll choose this one. So we'll say 4 equals 0 times -3 plus b. All right, so solving for the b value. 0 times anything is 0, so our b value is just 4. So that means I can write this equation as y equals, well, I don't really have to write 0x, right? 0 times x is 0, so I can just call this equation y equals 4. You might benefit here from seeing this visually. If you see this visually, I think it'll make a lot of sense to you. So here's that line graphed through those 2 points. And what you should notice here, you should see that this is a perfectly horizontal line, just like we expected. That's got to have a 0 slope. Now, the reason we're just going to call this y equals 4, because you'll notice any point I pick on this line, it doesn't matter what point I pick, I'm marking a bunch of them. All of the y coordinates for these points are 4. So everywhere on this line, y equals 4. So the best description of this line is just y equals 4. All horizontal lines are going to look that way. All right, now let's see if we can figure out the equation of a vertical line. So we're given line EF passing through 2 new points. Let's do the same thing. Let's find the slope again. So we have 4 minus -7 over 3 minus 3. And what you're going to notice is we get an undefined slope, right? Something divided by 0. We can't divide by 0 in math, so we call that undefined, which again is what we would expect from a vertical line. So far so good. We know this is a vertical line because of that undefined slope. But where we really run into trouble is if we try that same method, or either of the methods we've learned, either this or point slope form. How do I plug in an undefined slope? Well, the answer is you can't really. There's nothing I can do with this. 11 over 0 times x, I can't even really solve that out because I'm going to end up getting an undefined number. So it's hard to imagine what the equation of this line is going to be until we see it visually. I think if we see it visually, you'll see that the answer is actually quite simple. So here's our vertical line passing through those 2 points, right? Now notice this time, what stays constant is that the y value, rather the x value, excuse me, is always 3. All of these points, the x value is 3. The y value is changing, but the x value is 3. So the simplest way to write this equation is just x equals 3. Every point on this line, x equals 3, the x value is 3, right? It's just the y value that's changing. So the equation of a vertical line will say x equals some number. All right, here's some good stuff to add to your notes. Horizontal and vertical lines do not follow the traditional y equals mx plus b format. Okay, so you're going to have to approach them a little differently. Just some examples. Y equals 3 is going to be all the points in a horizontal line where the y coordinate is 3. So y equals is a horizontal line. Whereas x equals, like x equals -2, is all the points in a vertical line where the x coordinate is -2. So whenever you see these equations where it's just y equals and a number or x equals and a number, you're dealing with either a horizontal or a vertical line. One way you can tell, like if you're looking at the coordinates, if the x or y coordinates repeat, that's your indication that the line has either a 0 or an undefined slope, because that means you either have a flat line or a vertical line. Like for example, watch how we can do this really quick. So the equation of this line passing through -51, 8, and this got cut off a little bit, sorry. Let's just add the negative. -51, 100, right? What's the equation of this line? Well, just look. The -51 repeats, right? And it's in the x value. It's not the y value, it's the x value. So the equation of this line is x equals -51. There you go. Didn't even really have to do much calculation. Okay, let's try this one here. So we have a green line and a red line shown to us on a graph. What's the equation of each line? Okay, let's just think about it. How do we figure it out? What I want you to think through is what is staying constant. So let's take a look at the green line here. Let's just pick a couple points. Watch, we'll pick some points at random. Well, that point there, that is -5, 2. Okay, and then if we pick one higher up, let's go here. -5, 5, right? Okay, what stayed constant? The -5. And that was in the x coordinate, right? So our equation of this green line here is x equals -5, which is a vertical line. Perfect, because the x value is not changing. It's always -5. So for the red line now, let's do the same thing. Let's just pick, we can pick seriously any 2 random points. That one there, that is -3, -3. And then this one over here is 6, -3. Okay? Again, what stayed constant? What didn't change? Well, in this case, what was constant was the y coordinate had -3 both times. So our equation for this line is going to be y equals -3. Okay, and that's a horizontal line. Now, one last thing I'll end on here is, what's the relationship between these two lines? We don't see their slopes in their equations, but we do know that this slope is undefined because it's a vertical line. And then we know that this slope is 0 because it's a horizontal line. And we've learned previously that horizontal and vertical lines, 0 and undefined slopes, must intersect at 90 degrees. So you could also say that these two lines are perpendicular. Okay, let's do a couple practice problems. So determine the equation of a line that's parallel to x equals -9 and passes through 5, 2. All right, let's take a look. So parallel to this line, x equals -9. What I want to kind of do for you here, you could use Desmos and graph this, but I want to just show you, if you sketch it, you can figure out the answer pretty quick. So here's x equals -9. So all the points where x equals -9 would look like that, right? So if we want our line to pass through 5, 2, let's say that's somewhere right here, 5, 2. and we want it to be parallel to this line, well, that means we want a vertical line as well. So we want a line that has x equals. So what's the x coordinate of this point? Well, it's 5. So our equation of our line would be x equals 5. That's going to be parallel to x equals -9 and passes through that point 5, 2. Okay, what if they want now a perpendicular line that also passes through 5, 2? So let's do the same thing. Let's make our little sketch. So here's our sketch. X equals -9, so I'm -9 on the x-axis, and then everything that goes through -9. And now 5, 2, estimating is somewhere around here, right? 5, 2. Okay, now we want it to be perpendicular. So that means I want my line to be horizontal, right? Passing through this point horizontally. So a horizontal line is going to be a y equals equation, right? So I just need to take my y coordinate, y equals 2, and I'm done. All right, why don't you try this one? Why don't you pause this here before I go over it so you can see if you're getting it. Okay, hopefully you've had a chance to do it here yourself now. I want to show you that you can do this just very quickly if you know what to look for. You might still be graphing it on Desmos, which is fine, but watch how quickly we can do part 1. What's the equation of line LM? Well, looking at these 2 points, I noticed that it's the y coordinate that repeats. So the equation is y equals 1. That's all I had to do because that's the coordinate that repeats. Okay, what's the equation of a line that is perpendicular to LM and passes through M? Okay, so it's got to pass through M, so I'm looking at M's coordinate here, and if it's perpendicular, that means I need to go through the x coordinate, x equals 4, because you're going to have a line that's going to hit it in the opposite direction, but it's got to pass through that x coordinate. How about a line that's parallel to LM and passes through -3, -6? Well, again, parallel. That means I want to use an equation that is also a y equals equation because it's got to be going in the same direction. So I also want a horizontal line. So I'm going to go with the y coordinate of this answer, y equals -6. If you weren't quite able to follow that, I really recommend take a look at Desmos. Desmos will really clear this up for you. And you'll see that these are horizontal and vertical lines that are either parallel or perpendicular to the given line. All right, got a couple opportunities for extra practice. Both of these sites provide you some extra practice if you're into that today. And finally, you ready for the exit tickets? Good luck. Let me know if you have any questions.